Hi everyone, good morning, and I welcome all to the next session in Java. So in the previous session, we have seen about the constructors in Java programming language. We have seen what is a constructor and how that constructor is executed in Java. So the people who don't follow the previous session, they can have a look at the recorded video which was kept in the YouTube channel of our college. So please follow the previous class if anyone don't understand what is a constructor and how constructors are executed in Java. And in today's session, we start with the access specifiers in Java. And after the completion of these access specifiers, we will see the next topics in the syllabus. Right? So after completion of these access specifiers, we will see the things regarding this keyword, super keyword, etc. So before going to see those things, let us start today's class with the access specifiers, or we can also call them as access modifiers in Java. So in Java, there are three keywords which are used for access modifiers: public, private, and protected. So if anything is defined by using public keyword, it can be accessed in the same class, in the subclass, right? And in the same package and outside of the package also, right? So I will explain by using an example, don't worry. And if I define a variable or a method by using a private keyword, it can be accessed in the same class. It cannot be accessed in the subclass, it cannot be accessed in the package, it cannot be accessed outside of the package. And the same thing, if I define a variable by using the protected keyword or by a method by using protected keyword, that method can be accessed inside the class, inside the subclass, and inside the package, and we cannot access it outside of the package. And the last one is unspecified. If we don't use these three variables, or if you don't use public or private or protected before declaration of a variable or before declaring a method, then that particular variable or method can be accessed in the class and can be accessed in the package. It cannot be accessed in the subclass and it cannot be accessed outside of the subclass, right? So let us see. But in some versions of Java, an unspecified variable or method can be accessed in the subclass also. Right? Not right. I'm sorry. Next one. So let us see the things here. Let us move to the. So before going to see this keyword, let us see how this access specifiers will behave. Right? Let us take a new Java program. Here class is access specifiers AS, and let us see here. Let us see here. I have a variable. For example, I have a variable int a equal to 10. And I have one more variable public int, right, b equal to 20. And I have another variable private int c equal to 30. And I have one more variable protected int d equal to 40, right? If you observe, I have used four variables a, b, c and d, where a is an unspecified variable, b is a public variable, c is a private variable, and d is a protected variable. Now let us see let us see, and let us write one more class. Here my class name is AS1, right? And it is a subclass. Subclass in the sense we are following the concept of inheritance. So extends AS. Now AS is a parent class and AS1 is a child class. For example, here, what I want to do is, uh, there is one method m, right? There is one method m which will print all the four values, right? There is one method m which will print all the four values. At the same time, I am going to write one more method m1 here, right? M1, which is going to print all the four values. So in order to print all the four values, we can use system.out.println. So system.out.println, right? I'm sorry, system.out.println a, and then B, C, and D. Let us change it, please. B, C, and D. So let us write the same. Four lines of code in the method m, which was in the class AS1. So I'm writing the same thing in AS1, and let us see how this one will behave here. Right? If you observe, I have defined four variables with unspecified, public, private, and protected, and I have printed all the values of those variables in the same class. And this is the same class, right? It is the same class, and I tried to print all those values in the subclass. And at the same time, I am going to write one more class, right? AS2, right? AS2, and inside that class, what I want to do is I want to print all these values again, right? I want to print all these values again. That I am going to change the method name here. Now let us say it is M2, right? The method inside this one was M1. Let us take M1, and the method inside the base class was M, right? So now let us write the main method in Java, right? Let us take one more class AS3, right? AS3 here, public static void main string args, public static void main string args. Now let us try to create objects for all the three classes. For example, as1 space obj1 equal to new as, or as space obj equal to new as, right? And then let us try to create an object for the next one. So the next class name is as1, and the next class name is as2, right? So I am going to create objects for all the remaining two classes. AS1 object name is obj1, for AS2 it is obj2, right? So now I have created objects for all the three classes. Now what I want to do is, I want to print here, I want to execute the methods obj.m, obj1.m1, obj2.m2, right? So this is how I made a call to all the three methods. What these three methods will do, let us consider M2. All the code in the methods was same, but these methods are located in different classes. If you see the code, all the methods are going to print the values of the variables, right? Now, let us save the code. We have to save this code as as3.java because the main method was located in as3. We have to save it as as3.java. I try to compile, but if you observe, we are getting some errors. So let us have a look at all those errors, and now you can understand the importance of this public, private, and protected keywords. See, let us see the errors line by line. So the first error was at line number 21. If you observe the black color window, there is some error at line number 21. C has private access in AS. which means let us see the variable C, how the variable has been defined. C has been defined by using a private keyword, right? C has been defined by using a private keyword. So what we have studied here, if anything is defined with a private keyword, right? If anything is defined, I will show by writing something on the screen, right? If anything was defined by a private keyword, right? By a private keyword, if you observe here, it can be only accessed inside the class. We cannot access it in the subclass. We cannot access it in the package. We cannot access outside of that class. So here, let us move to the program. Here, C is private. So we can print C because this M is also in the AS, same class. But here, we cannot print C because it is another class. Because C has been defined as private. We cannot access it here. So let us delete this one because we cannot access C outside of the class because C variable is defined as private variable. And see, let us see the next error. So the next error was at line number 31. It is saying that it cannot find the symbol. And at the same time, line number 32, it cannot find the symbol. Line number 33, it also cannot find the symbol. Line number 34, it also can't find the symbols. So this is why, because this is why we are getting these errors, because here if you observe the program, AS2 is an independent class. It does not have relation to AS1. It does not have relation to AS. So here the compiler don't understand what is A, what is B, what is C, and what is D inside AS2. Because we have defined the variables in the program. We have defined the ABCD variables in the program. But the scope of this ABCD is from this particular point. The scope of ABCD is from this particular point to this particular point. Outside of this particular point, we cannot access ABCD unless and until the next class is a subclass of this particular class. Right? So if you observe this AS1, it is a subclass of AS. That is why we are able to access A, B, and D. Instead of it, although it is a subclass, we cannot access C. Why? Because C is defined as private. So here so the compiler is unable to find these symbols, right? Let us delete these symbols. Let us delete and let us compile it again, right? Still we are getting some error. I think we don't have the AS2 class, and still we try to create an object for AS2 class. That's why we got that error. I just compiled the thing. Just a second. Still, yeah, 1 second. There is no M2 method in the, and there is no obj. Let us save and compile the method now. So, sorry, compile the program. It has no errors, and run the program. It has printed some values called as 10, 20, 30, 40, and 10, 20, 40. Right? So this is the thing what we have, what we need to follow in while we are using these access specifiers in the program. If it is public, it can be accessed everywhere. If it is private, it can be only accessed inside the class. If it is protected, it can be accessed in the class, in the subclass, and in the package. And it is unspecified, we can access it only in the class. We cannot access it anywhere other than a package. Next one. Let us move to the next one. Yeah, this is the next one. This keyword, one of the important keywords in Java programming language. Generally, we will get some short answer questions from this keyword in the examinations, and at the same time, it is one of the interview questions while attending an interview on Java. Right? Next one. Let us see the usage of this keyword in Java. So there can be a lot of usage in Java with this keyword. In Java, this is reference variable that refers to the current object. So at present, we are working on an object, and whenever we use this keyword, that this keyword will refer to the current object. This can be used to refer current class instance variables. See the first point. This can be used to refer current class instance variables. Second one, this can be used to invoke current class method implicitly. We cannot call them explicitly, we can call it implicitly. And this can be used to invoke current class constructor. Third point. And fourth one, this can be passed as an argument to the method call. So while we are calling a method, we can pass this keyword. It will refer to the current object. And this can be passed as argument in the constructor call. This can be used to return the current class instance from the method. Right? I think it may be a little bit confusing. The people who are listening about this keyword for the first time, these things will be a little bit confusing, right? So I will show them in a program. So I will explain them in a program. Let us start with the first point. Let us start with the first point. So if the first point is that this can be used to refer current class instance variables, right? So we have studied in one thing in Java, the variables are of three types, or maybe the variables are of two types, we can say. So instance variables and local variables. If you see this one, if you see this A, B, C, D, these are called instance variables. And if you see, if you define a variable called as E, it is called as local variable because it is only local to that particular method M. And A, B, C, D are not local, they are inside the class and outside the method. So those type of variables are called as instance variables, right? So what we have studied here, so this instance variable, so this keyword can be used to refer these instance variables, right? I will show the usage here. So let us have one more Java program, right? And this one is T because we are working with T. T. Now, sorry, this keyword I have made it as right. Now let us start writing here. If I have a variable int a comma b comma c, right, and I have a method m, right? I have a method m where method m is also having these things int a, b, and c. So those things are different from these things, right? Those are instance variables, and these are parameters, right? What I want to do is a equal to a, right? B equal to b, c equal to c. One second. So I have written these statements, right? And then what I do is I have written one more class. The name of the class is T1, and there is one main method inside the class, public static void main string args, right? Now, what I want to do is I want to create an object for class T, right? And then one second. And now what I want to do is I want to access the methods. For example, if I want to call the m method consists of three parameters a, b, c. So we need to pass three integer values. For example, 10, 20, 30. Yeah. And then now let us see what will happen to this program. Definitely we will get an error. So let us see. Let us save the code first. T1.java, because the main method is in T1, and now I'm compiling the code. So there are no errors, but one second. It is just assigned, and after the assignment I will print all these values, system.out.println a and b and c. Saving the code, compiling the code. Just a second. Right. So if I compile the code, I am getting some errors. So what the errors we are getting? We are getting system.out.println A is unable to print the values of A, B. Just a second, just a second. I'm sorry. Let us take one more method here. The method name is m1. What this method will do is it will print the values of ABC. So after assignment, let us call the method m1 also, object.m1. Right now, save and compile the code. It's not producing any errors. And at the same time, if you observe here, the values we are getting is 0, 0, 0. We have given the values 10, comma 20, comma 30. Right? We have given the values 10, comma 20, comma 30 while calling this method. So the value of A will be 10, B will be 20, and C will be 30. So those three values are going to be assigned to ABC. Still, we are getting the values of 0, 0, 0. Why this is? The compiler will be in a confusion. When we write A equal to A, the compiler don't understand whether A is an instance variable or A is an parameter. If you see here, A equal to A, here there is one A which is an instance variable, and here is another A which is a parameter. When I write A equal to A, what is the thing that compiler will understand? Whether I am assigning a parameter to an instance variable, or am I assigning an instance variable to a parameter? Compiler don't understand the thing. It will be in an ambiguity situation. Ambiguity means it will go into confusion. Because of that confusion, the compiler cannot assign the given values 10, 20, and 30 to ABC. So there are no values assigned to ABC. But how we are getting 0, 0, 0? In Java, keep the things in your mind. In Java, while we define a variable as int A, and if we don't store any value inside A, that A will be initialized with 0 automatically. If we define a variable by using float, if we don't assign a value to float, still JVM will assign 0.0 to that float variable. If we define a variable by using Boolean, JVM will by default, it will add false. So there are some default values for all the data types in Java programming language. For integer it is 0, for floating point and double it is 0.0, for character it is null character, and for Boolean it is false. Whether we initialize it or not, these things will be automatically assigned to that variables. Right? So now if I define int ABC, the default value of integer in Java is 0. So that's why A is initialized with 0, B is initialized with 0, and C is initialized with 0. Now, if I want to bring the compiler out of the confusion, if I write this keyword here, this dot A equal to A, and if I write this keyword here, this dot B equal to B, and if I write this keyword here, this dot C equal to C, which will assign the parameters to the instance variables. Now, if compiler looks at this keyword, it will understand that this particular A belongs to instance variable. This particular B belongs to instance variable. This particular C belongs to instance variable because we have used this keyword. So that is the point which was maintained here. So that is the point which was mentioned in the slide. This can be used to refer the current class instance variables, right? So whenever the compiler is an ambiguity situation, whenever the compiler don't know whether the given variable is an instance variable or a parameter, when we use this keyword in our program, we will bring the compiler out of the ambiguity situation by saying that this particular variable belongs to instance variable. Now let us have a look at the output of this code, right? So this is the output of the previous code, but now let us see the code after writing this keyword here. If you see the output now, we are getting the output as 10, 20, 30. That is the beauty of this keyword. So this keyword is used to refer current class instance variables, right? So when one thing, when the variables, when these are different, if it is x, y, and z, and here there is no need to write maintain this keyword. We can delete this keyword, right? We can simply write a equal to x, b equal to y, and c equal to z. In such cases, compiler do not have any ambiguity. So here clearly it is producing the required output. It is clearly showing we are going to assign x to a. That means x is a parameter and a is an instance variable. During these situations, there is no use of this keyword. Whenever the parameter names are same as instance variable names, then we write the statement like this: a equal to a, b equal to b, c equal to c. In such cases, compiler don't know whether this a is an instance variable or a is an parameter. So in order to avoid the ambiguity situation of the compiler, if I use this keyword before the name of the variable, then the compiler knows that this is an instance variable. Now this is an instance variable. Now the things which are on the LHS of the equal to or instance variable, and the things which are after the equal to symbol are called as parameters, because there is no this keyword for this RHS, right? So that is the beauty of this keyword. And let us see the second point on this keyword here. The second point is this can be used to invoke current class method implicitly. Let us discuss this one, right? If I have a method yum, right? If I have a method yum here, and I have one more method, the name of the method is yum2, right? Yum2. What this yum2 is going to do is it is going to print system.out.println, right? System.out.println. What I want to do is, you don't call me, still I responded because of this keyword, right? You don't call me, still I have responded by using this keyword. Now what I want to do is, I want to just update this one, this dot m2, right? In the below main method, I don't call m2, I only called m1, but inside the body of m1 I have written this dot m2. Let us save the code first and compile the code. There are no errors, and run the code, right? If you observe the output, we are getting 10, 20, and 30 because we have printed A, B, C values here. And after that one, it has printed, you don't call me, still I responded because of this keyword. So we never call, if you observe the main method, we never made a call to method m2. We just called only method m1. But inside the body of the m1, we have used this keyword, and we have called the m2 method. So this dot m2 means the m2 is a method which was located in the present object. So execute that method. So if I execute the method m2, it will print this output. You don't call me, still I responded because of this keyword. So that is the output we have got here. So that is the meaning of the second point here. This can be used to invoke current class method implicitly. We cannot use this dot m2 explicitly. We can only call them implicitly. And next one, this can be used to invoke current class constructor. Let us see the beauty of the constructor here. We all know what is a constructor. We have seen it in the last class, right? If the class name and method name both are same, then we call it as a constructor, right? Now let us take one more program here, right? Here my program is tc. So we are working with this keyword along with constructor. That's why I have taken TC, right? So let us keep it as a main method and let us start working here. Class A, right? Inside class A, what I want to do is, yes, I want to write a one constructor. I want to write one constructor. So we all know constructor do not have any return type and the method name and class name both are same, then it is called as constructor. So if the class name is A and if the method name is A, then it is called as constructor. So use system.out.println. What it will print is constructor with 0 parameters. Constructor with 0 parameters. And then I have one more constructor. So this constructor will be executed whenever you made a call by you passing an integer value. So what this constructor will do is, so this constructor will print something like constructor with 1 parameter, right? And one more thing, I have one more constructor where constructors, just a second, where this constructor is having 2 parameters. And what this constructor will do is, it will print constructor with 2 parameters, right? So these are the 3 constructors I have created inside a class. And let us start writing the main method in. And inside the main method, right, inside the main method, if I want to execute all the constructors, I can simply create an object, a space obj equal to new a. So if I have written like this, it will print constructor with 0 parameters because we don't pass any parameters here. We don't pass any parameters here. That's why it will print the constructor with 0 parameters. And the same thing, if I have passed, for example, obj1 equal to new a of, right, new a of some 10, it will print a constructor with 1 parameter. And if I have written obj2 equal to new a of 10 comma 20, it will print constructor with 2 parameters. So this is how we can execute the constructors. And the people who don't understand how we can execute these constructors, they can follow the previous session. I have explained there how to write a constructor and how to execute the constructor. I have explained that. Please follow the previous session if anybody is having the doubts on constructors, right? This is how we can execute the constructor, right? Now, in order to execute 3 constructors in a class, we have created 3 objects, right? Now, let us see the output first. And then before going to see the output, let us save this code as tc.java and compile the code. So there are no errors. Run the code. So it has printed constructor with 0, constructor with 1, and constructor with 2 parameters. So now what I want to do is, I don't want to create 2 objects. I want to create only 1 object, and with that 1 object, I want to execute the remaining 2 constructors also. If I use this of 10, if I use this of 10, let us see the output. Compile first. So we got some error. Call to the first statement in the constructor. Instead of writing this one as a here, please write here, because we never return to the constructor of the execution. So that is why, please write, if you want to use this keyword or super keyword, please write this keyword or super keyword as a first statement inside the constructor. Don't write it as the second or as the last statement, right? Compile the code, run the code. If you see, it has printed constructor with 1 parameter, constructor with 0 parameters. But if you observe here, we have only created 1 object. With that 1 object only, we are printing, we are executing 2 constructors. This is possible because of this keyword. And if I want to make a call to the next constructor, if I can use this dot 10 comma 20 semicolon, it will execute the constructor which is having 2 integer parameters. Save the code, compile the code and run the code. You can see here, constructor with 2 parameters, constructor with 1 parameter, constructor with 0 parameters. That is the beauty of this keyword inside the constructors. See, when we start here, just a second. When we start here, a space obj equal to new a, right? It will start executing the constructor which is having 0 parameters, right? Which is having 0 parameters will be executed, and inside this one we have used this of 10. So the constructor with single integer parameter will get executed, and inside this one we have used this dot 10 comma 20. The constructor with 2 parameters will get executed. That is why we are getting this one as a first line, and next this one as a second line, and this one as the third line of output of the program. Let us see. I saved the code, compiled the code, and then run the code. So we are getting 2 parameters as a first line output, 1 parameter, and then followed by 0 parameters. So this is the behavior of constructors. This is the use of this keyword inside the constructors. Along with these usages, there are three more usages. This can be passed as an argument. This can be passed as argument in the constructor call. This can be used to return the current class instance from the method. Right? So the main 3 important, or the first 3. So I have shown the examples for those 3. And if anybody want to have the examples, please make a comment. I will show the examples for 4, 5, 6 also if time exists. Still we are in the first unit. Already first minute time has been came, but still we are in the first unit because Java is a vast syllabus and we need to work with examples on each and every topic. If you don't have example, it cannot be understood. So if I simply say this is a keyword which is used to access current class instance variables, current class methods, current class constructors, I can close with this point. If I close with this point, 99.9999% people don't understand what I am saying. What is instance variable? What is current class method? What is current class constructor? How it can be invoked by using this keyword? These all questions will run in your mind. In order to avoid all these questions in your mind, if I say one point, I need to show proof of that point. Now, then only the people will understand Java language, right? So for everything we need to write program. That is that will consume a lot of time. That is why it has been taking so many hours to complete the syllabus, right? So in the next class, we are going to see about the final keyword in Java. So before going to see about the final keyword in Java, I want to ask if anybody is having the doubts, right? If anybody is having the doubts, please make a comment here, right? Please listen to the class. If you don't understand the class once, please go through the class again. It's not a mistake, right? So some people may understand by listening at once, and some people may understand by listening multiple number of times, right? It depends upon the ability of the people, right? So the people who don't understand the things, please have a look at the class again. And if you still don't understand, you can have a comment, right? I'm ready to explain anything, any topic, right? So please learn the things. And once again, I'm requesting you to please practice each and every program, what I am saying in the class. At the same time, please practice the programs outside of the class by taking your own examples. Don't copy the things. Just know the syntax, just know how to write, and write the program of your own. That will be very helpful in order to develop the language skills, right? And I really thank each and every listener of this video for being here from the last 40 minutes and grabbing some knowledge regarding the access specifiers, public, private, protected, and usage of this keyword, how this keyword can be used to access instance variables, how this keyword can be used to access current class methods, how this keyword can be used to access current class constructors. Along with that, we can use this keyword as a return this keyword for method invoking and constructor calling, right? I thank each and everyone. And in the next session, we will meet you with the topic of final keyword in Java. One of the important keyword. This keyword is important. Final keyword is important. Static keyword is important. So there are some important keywords. On that keywords, we will see the theory part regarding the keywords. We will see an example on that keywords. Right? Please practice and have a good day.